a real shopping mall, but we tried to work in a quite real scenario, also if it's a simulation. We fixed the number of devices to 184, which is the number of devices that we actually found in that place during the survey. And we decided to consider as vulnerable the 7.5% of devices. We did many runs of the simulator and generated randomly the vulnerable characteristics of the different node. So we had simulation with more or less vulnerable individuals, and we computed the average. We used a Bluetooth range of 15 meters, which is kind of reasonable if we take into account that it's an indoor context and that actually we're using mobile phones. Okay. Some words about the results. We, in fact, consider two different situations in that context. The first settings tries to mimic what human beings will do going in and out shops in this shopping mall, so moving quite quickly from one shop to another, while a small number of devices will remain for a long time inside the shops. The simulation results are quite surprising. The number of infected devices between the vulnerable one was 82.4% after only 30 minutes average, and after 1 hour every vulnerable device is infected actually. The average time for the infection to propagate to every vulnerable devices was about 35 minutes. We tried also another setting in which we are simulating human beings in restaurant area or lunch area, something like that, where people are much more statically. They're not moving actually, not more, and only a small number of people displace to different area inside the lunch area. The result, well, as we expected, in fact, after having seen the result of the other setting, is quite surprising because the 100% of the vulnerable devices was infected after less than half an hour. In fact, the average time was 12 minutes. That's explainable because devices are quite fixed in their place, so the spreading is quite more effective. Okay. The simulation. Yeah.
The infection started just for one device, so we have considered just one device.
Yeah, at time 0, we have only one device infected in the simulation. Okay, let's sum it all up a little bit. The Bluetooth technology is definitely not only for the GIC anymore. We wander in many places and we found a ton of devices, so that's definitely quite spread nowadays. People doesn't seem to be really conscious of the potential threats because otherwise they wouldn't keep their phones with the Bluetooth turned on or in discoverable mode. And they're not conscious because they actually quite easily accept transfer from unknown people. And we didn't use trick like setting the Bluetooth ID to something interesting. Okay, the spreading techniques could be much more complex because we could use attacks, we could use social engineering, we can use the blue bag, which is kind of an effective instrument. In fact, in the end, the possibility to create, for an attacker to create a real complex attack scenario seemed more than an idea. We built that tool that can be used also for something evil, in fact. Okay, and anyway, the data we collected are quite interesting and can be used to do many interesting evaluation about that kind of things. What we're working on now is to actually implement a study in how many ways data could return back to something like the blue bag or the attacker headquarters. And also we are trying to develop more effective ways to auto-execute the worm itself on the device to which it propagates and to hide himself from the user. Okay, here you find some references about the Bluetooth tactical.
Yeah, I think we forgot one thing. Yeah. The survey software will be available on our company website maybe in September.
Yeah. Yeah, we need to polish it a little bit more, add some comments, take the shit out, and so on. Well, other links, the Trifinity guides for Bluetooth security, vulnerabilities, and so on, and the simulator stuff, so the mobility model, the network simulator, quite boring stuff. Okay, thank you. If you have any question, you're here. Okay.